Welcome to today's part of this SPSS methodology. This time with a unit on selecting cases or splitting our dataset up according to some kind of grouping variable. Why might we be interested in actually doing something like this? Well, for example, if we consider our variable body mass index here, we could calculate the mean for the whole dataset, but this then would be an average of men and women. As it might be prudent to assume that on average men have a different body mass index than women, it might be interesting to see whether, well, if we only consider the man, the result of the mean will actually be different from the result we got when we only consider women. Before we actually do this, we're going to run some kind of baseline scenario. So we first go descriptive statistics, frequencies, select the body mass index, click on statistics, select the mean, continue, and unclick frequency tables. So if we click now on OK, here we have our reference value for the whole data set with the 284 observations. We get an average for our body mass index of around 21.8. This is for both, for men and for women. Now if we want to select one of the subgroups, we would go to Data. Down here we have the command Select Cases. If we click here, we see in this case all cases are selected. So then we can click on the second part, if condition is satisfied, and click on If. And here we would enter in this upper field our actual condition. In this condition I said I want first to have the men, secondly the women. So I will start with selecting gender. Then I have to tell SPSS what gender should be like. So if I start with the man, this was 0, women was 1. So I need to tell him F1, the gender variable, should have the value 0. Meaning F1 should be equal to 0. If I click on continue and OK, I see basically nothing new happens here, so he won't calculate automatically what I did before, but he tells me here that he has selected or actually put a filter on, which means only those variables where this variable is 0, only those cases where those variables are 0 are considered. So if we now go back to analyze descriptive statistics and frequencies, we see whatever we put in before remains the same, so we can just click on OK. We see here this is the result only for the man, so the 124 observation, that's all men. And the men on average have a body mass index of 23.23. Now let's do the same thing for women. Let's go again to Data, select Cases, then on the condition. The easy choice would just go here and replace the 0 with a 1. However, we're going to learn something different in this part, and that's about this part down here. If we have this, well, curved line in front of this, this means we have an unequal to. So instead of the equal to, we put an unequal to here. So this means select all those cases which are not man. In our case, gender could either be 0 or 1, so man or women. There's no alternative. So all those who are not man, so all the women in this case, are selected by this. This is an interesting thing because later on it could be either the idea I want to select only specific cases, or I want to select everything but a specific case. And this would be for I would select everything but the man. If I click again on continue, OK, I see again down here basically he does nothing, but he sets a new filter. Filter here is unequal to 0, so being not man. Meaning I have to run my analysis again, click again, frequencies, OK. And then I get down here the result for women. So I see women have an average body mass of 20.72. So there's supposedly a different mean for the body mass index dependent on whether we have men or women. Later on, in the later unit, we will go into detail how I can actually test whether there's a difference in means, whether this is actually not a random occurrence that they are different, but that they are significantly different. That's not in this unit to be discussed, but for later time. Here we will return to our data selection window with select cases, and I want to add one additional aspect, because in this case I have only one condition. Now it could be that I want to have the man, so again equal to 0, that also come from a specific city. So for who city takes the value, for example, of 1. Then I need to add like gender should be equal to 1, and this is a logical and, city should be equal to 1. And this logical and, this is the ampersand here. So I would click this, then add city equal to 1. So this sign stands for logical ands, and I could also use, if I would be interested, a logical or. So either the man or those coming from city 1. The logical or, that's here, this line, the vertical line. Here, however, I want to have two conditions which have to be satisfied at the same time. For this, I use the logical and. So if I click on continue, here I could be remember I had 124 men. Here I see this is my new filter. So if I run this again, I see only 45 of the 124 men actually fulfill the condition, and well, the values are not so different. Here I have an average of about 23.2, and here it's 23.7, so it's roughly the same. However, well, in this case we've seen we can select different cases, and we can combine different conditions. So I have multiple conditions which need to be active at the same time. However, the most important insight in this lesson is something else. After you did any kind of selection, after you did anything at all with the select cases and you're finished, always return here, click again on select cases, click again on all cases and on OK. Basically then only tells us filter off, use all. This is very, very important. Why is this so critical? Well, because if you didn't activate this filter, all the following analyses will only be done for men from city 1. So you will only use those 45 observations and not the full data set of 284. So this can screw up the results, bias any kind of results, very fast. Okay, so far so good. So particularly in the beginning we've seen how we can compare men and women. Okay, men and women, that's only two possibilities. That's not this big of a thing to be done. I run the same part twice, I do two selections. This is still manageable. But now imagine you're considering different counties, different cities, different regions. There could easily be that you have to select 20 or even more different cases, different groups. So this will result in a lot of work. And to make our life easier in this context, we can use, also with data, the part split file. In split file we have two options. We can first go with organize output by groups, and again we can use gender. Then it will provide the same output for all the groups contained within gender. So we'll do this once for men and once for women. If I could also do this with city, then he will do the same result for all the different cities. If I click OK, as with the select cases, I see here he only tells me sort cases by. Doesn't change anything with the output, so I again have to run the corresponding command, so descriptive statistics, frequencies, and OK. And here I get my result. In this case he tells me for the man, gender equal to male, you get this result. For gender equal to female, you get that result. So it's the same as I got before, but it's more compact. Well, okay, more compact, but still it's two different tables. So it might be more interesting to have the same result in one bigger table. And this can easily be done by going back to data, split file, and select the second option, the compare groups. So if we click on compare groups, the rest we leave as it is. Click on OK. Again he tells us sort cases, split file, layered this time. We go back to analyze, descriptive statistics and frequencies. Click just OK. Here we get one summary table with the results for men and the results for women. And this is a very compact version giving us all the results. And well, we could do the same, for example with the cities, where we had more observations, again with split file, not run with gender, but here with cities. Click OK. Run our analysis once more. Click on OK. And here we see for Cologne, Düsseldorf and Wuppertal, we get the results all nicely in an overview in this table. Well, the same thing which applied for select cases also applies to the split file command. After you finished working with this, go back to the command and select the first option, the option of analyze all cases again, and click OK. Then he tells us split file off, meaning in this case you will again use the whole dataset, all 284 observations. And well, if you wouldn't do this, all your analyses would be split up for the 3 different cities. This could be an interesting way to go, whether if you want to see, for example, whether the results, for example of linear regression, differ for the different cities. Some relations are stronger established in one city than in another, but usually this will just disturb your work. So always recall, whenever you do something with one of the 2 commands here, after you finish, return to the command, select all cases again. With this said, this is then all I wanted to talk about in this session. I hope you enjoyed listening to it and took something away for your own sake. And well, if you want to see more of this, feel free to visit the rest of this SPSS methodology. Until next time, see you and goodbye.